Good day. Thank you for tuning in to this session. Today we will be discussing the problems that were set in 2024 in the team competition, the South African team competition, arranged and coordinated and organized by the South African Mathematics Foundation. The team competition comprises of junior and senior learners from high school, and each team of 10 are given 10 individual papers, as well as one paper which has got all 10 team questions. And all the members of the team are expected to participate and try to work those problems out. So with those few introductory remarks, we will go straight into the problems at hand. Okay, so here we go. First question. Sebo has 2,024 rands, and he wants to buy chocolate bars that cost 23 rands each. Okay. So let's see how many chocolate bars he can buy. So you have to divide 2024 by 23. Now, normally I factorize and cancel. So I can see 8 goes into this because the last 3 digits is divisible by 8. And 8 goes into this 8 times 253 times. 2 plus 3 is 5. So this is 23 goes into this 11 times. So you have 88. Okay, you can see divisibility by 11 comes in. Okay, now they say there is a promotional offer from the chocolate shop manager. For every 3 chocolate wrappers submitted, you will give Sebo 1 chocolate bar free. Okay, so he's got 88 chocolate bars. And I presume he's going to save all the wrappers. And we're going to see how many sets of 3 there are in 88. Okay, to get for every 3 chocolate wrappers, you will get 1 chocolate bar free. So he gets 88 divided by 3 is 29, remainder 1. 3 times 29 is 87. Okay, so he's got, with these 29, he can get 29 chocolate bars. Free choc bars. Okay, now that's not the end of it, because from these 29, you can get another 29 wrappers. And if you take that 1 wrapper which you got from the previous one, he's got 30, which allows him to get 10 free chocolate bars with these, but there are no wrappers remaining. Okay, and now with those 10, he can make 3 and 1 remainder. 3 goes into 10. 3 times you can make 3. And with those 3, you can make one more. Exactly. And he has one spare. Actually, he'll have 2, because this one, together with the one that remained, he will have 2 spare, but that's not enough to make any more chocolates, get any more chocolate bars for free. Okay, so this is where it stops. So the question is, what is the maximum number of chocolate bars servo can have? So you have to add up all these things. You've got the 88 plus 29, 111, 120, 89, 117, 127, 131. So the number of chocolates he has is 131. All right. And as usual, we quickly look at the solution which I have and see whether my calculations were correct. Yes, I see 131 at the bottom. So it coincides with right. So now let's get on to the next question. Zulile, Yondo, and Zinchle are each one of the following types. Right, so it's not clear, but it seems to me that there are three types there. Truth teller, we'll call it T. T for truth teller. And there's one of them is a liar, and the other one is an opportunist. The opportunist, he can lie or tell the truth. Okay. So now we need to know, each one makes a statement. Zulila says, I am not the truth teller. So he says, let's put it symbolically like this. He says, I am not the truth teller. And Yondo, he says, I'm not the opportunist. And Zinschler says, I am not the liar. Okay, now they always lie or they always speak the truth. Okay, now the question is, which type does Zinschler belong to? So you don't know. These guys can be any one of the 3 types. You just meet them at random. And all right, so normally this is a good example of a logical problem. We try to prove it logically. So let's start with X. Let's see whether X is the truth teller. Suppose you say, is X the liar? Well, if he is a liar, then he's speaking the truth when he says he's not the truth teller, right? So we can't make any, Yeah, okay. If he is a liar, then he's not the truth teller and he's speaking the truth. And that can't be possible. So X is speaking the truth. When he says he's not, when he says he's not the truth teller. Okay, so this is impossible. So therefore, X is the truth teller. Oh, wait a minute. So X is one of the other two. X is O or L. Okay. Now let's X is O or L. So that means let's have a look at Y. Now, if X is L, if X is lying, then he's speaking the truth when he says he's not the truth teller. So if X is L, you have the same problem. I can say similarly, X is not L. Prove by contradiction again. Suppose X is a liar. So what does it mean? He'll always lie. Now here, he says he's not the truth teller. So therefore, he's speaking the truth because he's a liar. You can't be a truth teller and lie at the same time. So X is not a liar as well. So therefore, it means that therefore X is O. Only three types. So X is the opportunist, right? Now, the question is, Sinschler says is not a liar. So if X is an opportunist, it means that these people, they are, one is T and one is L. Okay, so suppose, let's have a look at Y. Okay, now Y says is not the the opportunist. And he is one of T or L, so he's speaking the truth, right? Okay, now let's have a look at Z. Suppose Z is not a liar. Z is not the liar. Suppose Z is not the liar. Now we said that it's going to be T or L. So therefore Z is T. And that makes, so what he is saying here, when he is saying that he's not the liar, he's speaking the truth. It's very tricky, these logical problems. So they say, which type does Zinschler belong to? And I came to the conclusion that he belongs to the T group. But the other one is, suppose if you look at Y, he says he is not the opportunist. So Y is also speaking the truth. Let's look at Y. Y is speaking the truth. He says, I am not an opportunist, and we just came to the conclusion that X is the opportunist. So Y is speaking the truth. And therefore, Z is actually the liar. Contrary to, oh God. Oh, thank God I can get this back. So if he is the truth, then Z has to be the liar. And if he says I'm not a liar, then he's lying. Right. So this is okay. So it is quite true that, yeah, so you have to go to Y and decide that he's speaking the truth. So the answer is Z is a liar. And the reason for that is I've identified Y to be the opportunist. I've identified X to be the truth teller. And therefore, Z has to be the liar. And when he says he's not a liar, he's lying. So that's fine. So Zinschler is the liar. Oh, this is quite a mouthful. It's a logical problem, and usually these logical problems you start like this. You assume the opposite and come to a contradiction. That is how I like to deal with these problems. There are some people who do it directly. I don't have the sufficient intelligence to do it like that. I do it by contradiction. Okay, so let's go and see whether Z is in fact the liar. All right, okay. At the end, we say that Z is the liar. So I'm displaying this so that when you are doing the recording again, when you go through this, you will follow the argument, even if you didn't do that now. Okay, let's get on to the next problem, question 3. It says that 2024 can be written as a sum of cubes of 8 different natural numbers. So which numbers between 1990 and 2024 share the same property? In other words, which other numbers between these can be written as the sum of cubes of 8 different natural numbers? Now, this actually requires a little bit of insight, this problem. You see, we are living now in the 2025 year, and by now, you should know a lot of properties of 2025. And one of them is that it's 45 squared. It's a square number. Now, another interesting thing about 45 is that it's 1 plus 2 plus 3 plus 4 all the way up to plus 9 squared. And a very useful formula is that this is the same as 1 cubed plus 2 cubed plus 3 cubed all the way up to 9 cubed. Very interesting formula. That's the sum of the first n cubes. This is the sum of the first n cubes. N here is 9. N cubes is equal to the square of the sum of the first 9 numbers. Right. This is one of the most beautiful formulae that I've come across. we can check it out. You can say 1 cubed is 1, which is 1 squared. All right, let's try 1 cubed plus 2 cubed. 2 cubed is 8, 8 plus 1 is 9, 9 is 3 squared, and 3 is 1 plus 2. See, 1 plus 2 all squared is 1 cubed plus 2 cubed. Let's try 3 cubed. Now you're adding 27 to the previous answer. So that's 9 plus 27, which is 36. And 36 is 6 squared. And 6 is 1 plus 2 plus 3. See, that's quite interesting. And one can prove that this is always true. Then 1 cubed plus 2 cubed plus 3 cubed all the way up to plus n cubed is 1 plus 2 plus 3 all the way up to n all squared. And there is a formula for the sum of the first n natural numbers. Okay, you can simplify this even further. But this formula by itself is quite fascinating. Okay, so in other words, 2025 is this. So now this is the sum of cubes of 9 different natural numbers. So I want to take out one of these and see if the answer, then if I take out one of these cubes, then I've got the sum of 8 cubes, and I want to know that sum lies between 1990 and 2004. So what you have is 2002. That is 2002. I'm going to remove one of these cubes. Let's call it x minus x cubed. Then I've got the sum of 8 cubes, right? And that lies between 1990 and 2024. And because this year is a sum of 8 cubes. And that's the question. Which numbers between 1990 and 2024 satisfy this property? Now, you can make x cubed the subject here. You bring x cubed to the other side, then you get 2025 minus 1990. And here, if I take x cubed to be on this side, then I've got 2025 minus 2024. If you take this and take the x cubed, you have that. You can make that less than or equal to maybe. All right, so which numbers between this have the same property? So in other words, you want to know what is this? This is 34. So now this becomes easy. You want to know which cubes lie between 1 and 34. Right? So x is 1 or 2. 2 cubed is 8. That lies between 1 and 34. And 3 cubed is 27. That lies between 1 and 34. But 4 cubed doesn't. So there are 3 values for x. And you want to know which numbers satisfy this property. So you have to take out the numbers are it's 2024, 25 minus x cubed. And when x cubed is, when x is 1, then you've got 2025 minus 1. And when x is 8, then x is 2 in other words, Then you've got 2 cubed is 8. So 2017 is one of them. And when x is 3, then x cubed is 27. And you take away 27 from 2025, you land with that. So these are the numbers which can be written as a sum of 8 cubes. Just a select few of numbers. Like for instance, if you want to know what is this, here you have taken away 1. So it will be 2 cubed plus 3 cubed plus 4 cubed all the way up to 8 cubed will give me the first answer. All right, like that you can get the others. So that takes care of, they say which numbers, yeah. So they say between, so maybe you're not allowed to include 2024. Because between means strictly. So there are 2 numbers. So these numbers can be written as a sum of 8 different natural numbers having the same property. Okay, let's go on. I'm still in question 3. Let's oh, you can see I've got the same answer. At the bottom, the required numbers are 2017 and 1998. See, they also, to say it's between, it suggests that it's not the endpoints. I can say 3 is between 2 and 4, but I can't say 4 is between 2 and 4. Right? You're not allowed to include the endpoint. So that's how you have only 2 answers. Now it is given that the reciprocal of an odd prime number can be written as a sum of reciprocals of 2 unique even primes, even numbers A and B, where A is greater than B. Okay, now how do we go around doing this? So you want to write 1 over P, the reciprocal of, let P be such a number. So the reciprocal of any odd prime number, that's 1 over P, can be written as a sum of the reciprocals of 2 unique numbers. The reciprocals of 2 unique numbers. There's no other way in which you can write 1 over P as where A is greater than B. Yeah, so I just want you to notice something, and that is if you take 1 over P plus 1 over P plus 1, or make it minus. I want to write this. This is the sum of 2 things. Now this is equal to actually 1 over P into P plus 1. If you simplify that, you can see quite accurately. You'll come to this. So 1 over P is equal to 1 over p plus 1 plus 1 over p into p plus 1. Okay, so there we have it. You have that the reciprocal of the odd number, p is odd. It's the reciprocal of two unique even numbers, a and b. Well, if p is odd, then p plus 1 is certainly even. And this is the next one, is p plus 1 is an even number at the bottom. So, because this is the product of two consecutive numbers. The product of two consecutive numbers is always even. P and p plus 1 are consecutive. And they are even because one of them will have to be, one of those factors will have to be even. In this case, p plus 1 is even. Okay, so now we have that. Let's say write the numbers a and b in terms of p. So a will have to be, they say a is greater than b. So a will have to be p into p plus 1, and b is p plus 1. Okay, this is p plus 1 times a positive natural number. Oh, yeah, it's actually greater or equal to 2. So a is certainly even, because one of the factors of a is even, and b, being an odd number plus 1, is also even. So we have written this 1 over p as the sum of two numbers, reciprocals of two numbers like this. So this actually solves the problem. Only thing is, that these numbers are unique. We don't know whether this is the only way in which 1 over p can be written. All right. Okay, we wouldn't go too much into that. We can see what the answer is. Write the numbers a and b in terms of p. There's your answer. Okay. We'll go on to the next problem.